So we have a landscape architect who's designing a garden that needs to be a total of 3,000 square feet. On three sides it'll be bordered with planters filled with flowers costing $45 per foot. The fourth side will be $20 per foot. We want the minimum total cost. So here's our garden, and we'll assume that it's going to be rectangular, and let's call this x and this y since we don't know them. But we already have our constraint equation because we know x times y must be 3,000. Now, we need the function we're trying to optimize, which is the cost. Well, three of these sides are going to cost $45. So maybe this side, this side, this side cost $45, and this is the $20 side. So putting that together, notice we have 45x plus 45x plus 45y plus 20y is our cost function. So we have 90x plus 65y is our cost function we're trying to minimize. Now what we do is we take our constraint equation, solve it for one of the variables, plug it in, and get it in terms of one variable. So perhaps I solve for y. So 3,000 over x. And I'm going to plug that in now for my y here. So I get 90x plus 65 times 3,000 over x. And we may want to simplify that just a little bit. So 65 times 3,000. So we get 90x plus 195,000. And I'm going to write it as x to the minus first because our next step is going to be to take our derivative. So c prime of this guy is 90 minus 195,000 x to the negative 2. So we'll set that to 0, and this is what we need to solve. So having this equal to 0, these two need to be equal to each other. Well, remember, this is basically 195,000 over x squared. So we cross multiply, and we get x squared equals 195,000 over 90, and what we get then is x is going to be approximately 46.55 feet. Now, we were only asked to find the total minimum cost. So we're going to want to use a nice exact value for x. So x is the square root of, let's write it as a fraction, of 2166 and 2/3. Now what we'll do is we'll take that x. We don't need to find y. We can. Y would be 3,000 divided by this number, so if we wanted it, our y comes out to be 1.38 feet. But to get our to get our total minimum cost, we can just plug our x value into our cost function right here. So, getting our total cost, we get $8,378.54.